Very good morning, dear students. As we were doing probability, and in the last lecture, we have completed conditional probability. We have understood the conditional probability and did some question. One question, I think you should understand this one, so I'm doing that. Then we'll start with the next topic, that is multiplication theorem on probability and independent events. Okay, so the question is, in a certain school, 20% of students failed in English, 15% of students failed in mathematics. Okay, let us try. 20% of students, they are failed in English, 15% of students, they are failed in mathematics, and 10% of the students, they are failed in English and mathematics both. Now a student is selected at random, so we have to find that if he passed in English, this is the condition. Okay, if he passed in English, what is the probability that he also passed in mathematics? Okay, so we need to find that probability. So let us consider A, B, the student passed in mathematics. Okay, and B, event B, student passed in English. Okay, so we need to find the probability that that particular student which we have to pick will be passed in mathematics, given that he's passed in English. So required probability will be probability of A given B, which is nothing but A intersection B upon probability of B. Okay, now these are the cases for the passed one, and we have the data for the failed one. So we need to just see that what will be the passed data. Okay, so in English, 20% are failed, that means 80% are passed. Okay, so see, 80% are passed, 15% are failed in mathematics, which means 85% are passed, and 10% are failed in English and mathematics, so 90% are passed in English and mathematics. Okay, so for the past one, let us find that how many will be the past one. Okay, so how we will calculate, that is, if you could see, probability of A union B is equal to probability of A plus, sorry, number of B minus number of A intersection B. Okay, so how we will do this? So we'll just replace with the values. So 90% is equal to, see, percentage, if you could can understand, we it will be divided by 100, and here also divide by 100, that 100 to 100 will be cancelled. So we can understand, I'm directly writing 90 here. For number of A, that is 80 plus 85 minus number of A intersection B. Okay, now take number of A intersection B here and 90 that side. So number of A intersection B will be 80 plus 85, 165 minus 90, that is 75%. So number of A intersection B, this means that how many students are passed in both English and mathematics, that is 75%, and this is what our A intersection B. So in this we can put probability of A intersection B will be 75 by 100, and probability of B will be 80 by 100. Okay, if you cancel 75 upon 80, so 75 upon 80, this can be cancelled with you can cancel with 5, so 1, 15, and 16. 15 by 16 will be the probability. Like this we have to do. Okay, now multiplication theorem on probability, what does this mean? This is just a simple thing. Okay, what does this say? As we know by the conditional probability, that probability of A given B is nothing but probability of A intersection B upon probability of B. Okay, if you take this probability of B this side, so probability of A intersection B can be expressed as probability of B into probability of A intersection B. This is called the multiplication theorem on probability. Okay, it can be extended for the 3 events also. We have considered for the 2 event, that is A and B. It can be extended for the 3 events also. So for that 3 event, please see from the book. Okay. So this is what all about multiplication theorem on probability. Now let us come to independent events. Okay. I told you what is the independent event. The 2 events are called the independent event if the occurrence or non-occurrence of one does not affect the probability of the occurrence of the other. Okay, that is what the independent event means. All right. So say for example, if we take, when a coin is tossed twice, the probability of getting a head on the first toss is half. The probability of getting a head on the second toss is also half, regardless of the outcome of the first toss. Okay, so that is what, like, you can understand that whenever a coin is tossed, okay, it is an independent event. Okay, because occurrence and non-occurrence does not affect the probability of the occurrence of the other. So that is what the independent event means. Okay, now how can we understand this? In the 11th class we have seen that if two events are independent, then their probability of A intersection B will be probability of A into probability of B. All right. So if you have the independent cases, then this is true, that probability of A intersection B will be the product of their both the probabilities. Now if I put this value here in this formula, so see, a new result we can form. In place of A intersection B, we can write probability of A into probability of B upon probability of B. Probability of B to B we can cancel, and we are left with probability of A. Okay, what can you understand from this? Probability of A given B is equal to the probability of A. That means whatever given to us, there is, it doesn't matter to us. Why? Because these are the independent events. Okay, so even if you give something, or even if you condition something, so that will not affect us, because the probability will be same. So this is what the meaning is. Okay. So for example, if we just take a practical example, okay, we'll see that in the illustrative examples. There itself I will explain you the meaning of this. Okay. Okay, so let's start the question. I'm reading. An urn contains 10 black balls and 5 white balls. So one urn is there. Okay, it is having 10 black and 5 white balls. So total 15 balls are there. Okay. Two balls are drawn from the urn, one after another, without replacement. We have to draw two balls. Okay, one after the another, not in a single pick. We have to one after the another. Without replacement means we don't have to replace it. Okay, from the 15, if I pick one, so we are left with 14, and from the 14 again, if I pick one, we are left with 13. So like that we have to do. Okay, now what is the probability that both balls are black balls? Now we need to find the probability of getting the black balls. Okay, so in the first, what will be the probability of getting black ball? In the very first pick, how many black balls are there? 10, and total 15. So 10 by 15, which is 2 by 3. So on the first draw, the probability of getting black ball will be 2 by 3. Okay, probability of, this is the first draw. Okay, now for the second draw of getting black ball will be what? Can you tell me? See, from the 10 we have taken one ball. Okay, without replacement, so we are left with 9 balls of black, and totally we are having only 14 balls, so 9 by 14 will be the case. Now what will be the required probability? Both balls are black, they both are independent. Okay, because they both are independent events, because this one is not affecting the another one. So we need to multiply both their probabilities, that is 2 by 3 into 9 by 14. So what we are left with? 3 by 7. So 3 by 7 will be the probability that both balls are black balls. Okay, See, you can understand in this way. If you are not able to understand how they are independent, okay, wait, just see. You can understand in a way that for the second row, let us consider these two as two events. Okay, see, let probability of A be the event of getting the black ball. So it will be 10 by 15, that is 2 by 3. And let us consider B be the event of drawing a black ball in the second chance or second time. So probability of B given A. Why I'm putting given A? That I need to draw in the second B event, I need to draw a black ball, and condition A, that means already I have drawn a black ball, because they have written a very important word, that is without the replacement. So without replacement we need, so we need to find the probability of B given A. So it will be what, the same, that is what we did, 9 by 14. Okay, now by the multiplication rule of probability, we have probability of A intersection B, which is probability of A into probability of B given A. So that is what, 2 by 3 into 9 by 14, and finally you will get 3 by 5. So you can understand in such a way. Okay, okay, if you could not understand the independent event, let me just give you one example of it, how we can understand this one. Okay, like say for example, we have a deck of 52 cards. Okay, and from there we are trying to draw a card. Okay, now I'm giving an event ENF. Event says that it should be a card of spades, and F be a event that it is an ace is drawn. Okay, so can you tell me what will be E intersection F? It will be an ace of spade, right? Okay, if I ask you what will be the probability of E, the probability a card of spade, how many spade we have? 13, and total 52, 1 by 4. If I ask you what will be the probability of an ace, so it will be 1 upon 4, because ace, there are total 4 ace. Okay, and the total cards are 52, so it will be 1 upon 13. Okay, can you tell me what will be the E intersection F? Ace of spade, how many cards are there which is ace of spade? Only one, so 1 upon 52. Now if you actually multiply probability of E into probability of A, let's see what we are getting. 1 upon 4 into 1 upon 3. Are we getting 1 upon 52? Correct? Which means that E and F are independent event. That means if you draw a card of spade, it will not affect an ace, and or if you draw an ace, it will not affect a card of spade. So from here it proves that these two events are the independent event. Now the things could be clear to you. Okay, let's do some question. Okay, so now I'm reading the next question, that is, a ball contains a bag contains 4 red, 3 blue, and 2 white balls. Okay, if 3 balls are drawn one by one without replacement, okay, this is very important, then what is the probability that all 3 balls are red balls? We are trying to draw 3 balls, and we need to find the probability that all the 3 balls are the red balls. Okay, so we need to consider 3 events. Okay, so let A, B, C be the events of drawing the red ball in the first, second, and third draw. Okay, so what is the probability of A intersection B intersection C by the multiplication as I explained, you can extend that multiplication law in 3. So let me just tell you probability of A intersection B intersection C. The formula is probability of A into probability of B given A into probability of C given A intersection B. So please learn this formula. Okay. uh, Now we need to find this one, and this one. These three things we need to find. Okay, it's easy to find probability of A. Yes, 4 red balls, and total how many? 4, 7, 9. So 4 by 9 is the probability of A. What it will be the probability of B given A? Probability of B, this is what? This is the second draw of drawing the red ball. Okay, so we have total 3 and one ball is already drawn, so there are total 9, so we are left with what? 7. Probability of C given A intersection B. C is what? 2 upon sorry, here 8 will come. Okay, 9, we are left with 8. Then probability of C given A intersection B will be what? 2 upon now we are left with only 7. Okay, now just put the things here: 4 by 9 into 3 by 8 into 2 by 7. Okay, this is cancelled, this is cancelled. 1 upon 21 is the final answer. You know, you can alternatively do this question in a way that this particular problem is equivalent to drawing the 3 red balls in a total of 4 red, 3 blue and 2 white. So what the required probability here will be 4C3 upon 9C3, because you need to draw 3 red balls. So simultaneously you draw the 3 balls, or one by one, that is same at a time. So for this question only, I'm just giving you this type of alternative alternative solution. So 4C3 upon 9C3, if you will calculate, you will get the same answer as that. Okay. All right, let us do one more question. Okay, let's do one question which is on the verification whether A and B are independent or not. So the question is, two dice are thrown simultaneously. Okay, and we are giving A event B getting 6 on first die, and B we are giving getting 2 on the second die. All right, now we need to verify that are A and B independent or not. Okay, so let's see. Okay, what will be the sample space of A getting 6 on the first die? So it is 6 1, 6 2 and so on up to 6 6. And what will be the sample space of B getting 2 on the second die? So it's just 1 2 2 2 3 2 and so on up to 6 2. Okay, if I ask you what will be the A intersection B, so in both of them we have 6 2 pairing common. Okay, so what will be the probability of A? Can you tell me? There are total 6 and we have the total outcome 36. So 1 upon 6 we are getting. Okay, keep it. What will be the probability of B? There are total 6. So again 6 upon 36, 1 upon 6. Okay. Calculate probability of A intersection B. There are only one pair and total 36. So 1 upon 36. Okay. So how can we prove that A and B are independent event? So multiply probability of A and probability of B. Just multiply. Okay. So probability of A into probability of B will give us 1 upon 6 into 1 upon 6, which is 1 upon 36. Okay, and the probability of A intersection B is also 1 upon 36. So from here it confirms that event A and B are independent event. I hope you understood this. Okay, so let's do another question. I'm reading this question came in ISC 2003. Okay, one bag contains 3 white, one bag contains 3 white, 7 red and 15 black balls. Another bag contains 10 white, okay, 6 red and 9 black balls. Okay, one ball is taken from each bag. Okay, one ball we have to take from this bag and this another bag. us give them bag 1 and bag 2. So from both of them we need to pick one ball. Okay, then find the probability that both balls will be of same color. Okay, so we need to find the probability that both the balls whatever we pick from bag 1 and bag 2, that should be of same color. Okay, so what will be the required probability here then? See, it will be probability of one white from bag 1 comma one white from bag 2 plus probability of one red from bag 1 comma one red from bag 2 plus probability of one black from bag 1 comma one black from bag 2. Can you understand this? The required probability, we need to add the three probabilities like this: one white from first one and one white from second, plus, because it should be of same color and we don't know the color, so that is why we have to take all the three and we need to add their probabilities. Okay, so that would be the required probability. Okay, so one white from bag 1, so there are three white, and total how many? 25. So 3 by 25 into 10 upon 9 plus 50, 20, 10 by 25. Okay, plus one red from B1, that is 7 upon 25 into here red are 6 upon 25 plus 15 upon 25 into 9 by 25. So finally there are the denominator is same, so upon 625 will be the same. 3 into 10 30, 7 6 are 42, and 15 into 9 it will be 135. Okay, so 30 plus 42 plus 135, just add it and get the answer of this one. Okay, so like this we will do. So I hope you have understood the today's lecture. We'll come up with more and more question in the next lecture, because next lecture I will cover with this exercise only. So in the next exercise we'll see more and more different question, new type of situations. Okay, till that, do practice. Thank you so much. Have a nice day. Bye bye. Take care.